Okay, now that we have our ejaculate that we've collected from Millennium, we've come back into the lab. I took the baby bottle off of the AV, removed the filter, which collected all of the gel in the ejaculate, threw it in the trash can. So we are left with our baby bottle liner with our semen sample. We generally put it directly into the incubator so it stays warm. We don't want it to cold shock sitting out on the counter. And there are two analyses we want to do relatively quickly once it's been collected, to kind of make some decisions on how we want to store this for later. So we have our semen sample here. The first piece of equipment I'm going to use is a densimeter, which gives us a count of how many sperm cells per milliliter there are in this semen sample. So I want to very gently mix it together a little bit because the sperm cells will collect on the bottom after it's sat for a little bit. So I use my pipette here, draw up a sample. We'll put the rest of our ejaculate back in the incubator. I have already zeroed this, so I will add our semen sample, gently mix it. We will add a cap. I want to gently invert it a little bit. There is formalin that was already in this, so that's what I use to zero it with our container here. So it kills all of those sperm cells immediately. It basically fixes them in there. So this machine is able to detect the difference in light as it shines through here and can estimate how many sperm cells are in each mil of our sample. So we place it back in the machine, hit go. While that's thinking, the next analysis we want to do to make our breeding and storage decisions is estimate motility. So again, we'll kind of mix it up gently a little bit. Use our glass pipette. Use a slide cover. Place it on the microscope, find the semen with the rough focus, and then scroll through our sample with a fine focus. So again, this is a subjective categorization of motility of this sample. There are a multitude of different pieces of machinery that can do this a lot more accurately. However, they go up in expense the more accurate they are. We can talk about the iSperm, which we have too, that can do a lot of these same things as well. However, this is what we've used for a long time, and this is how we're kind of calibrating ourselves to make sure our other piece of equipment kind of lines up with what we've always done. So when we look at this, I want to start with, is 50% of these sperm cells moving? I would say no. So is at least 25% of the sperm cells moving? I would say probably. So we're somewhere in the 25 to 50% motility range. And this is raw semen on this slide. So the longer it sits there, the more it's going to die. So as we kind of talk through this, we want to kind of think about what it looked like at the very beginning. You need to take a a pretty quick assessment when you put it up here, particularly for this stallion who tends to die off pretty quickly. So as we sit here, you can already see it even looks like less is moving now than it was. So we're in the 25 to 50% range. Do we think it's closer to 25 or closer to 50? I personally think it's closer to 25. So do we think it's better than 25? Definitely not the longer we look at it. But I think that he was in that 25-ish% motile range when we looked at it. Also, we want to measure total progressive motility. So this sperm here who's swimming in a circle like this, that would, although it's moving, you would include it in total motility. It would not be included in progressive motility. So for those sperm cells to be counted as progressively motile, they have to be going somewhere. So you want to make sure these ones you look at, they're going somewhere, not wiggling in place, not turning in a circle, that sort of thing. So we try to only count the ones that are actually moving forward and going somewhere. So I would have put him about 25%. Historically, there have been research projects that show people aren't really good at doing this. So that's how we've developed, or why people have developed machinery that kind of does this throughout the years. The gold standard is CASA, computer-assisted semen analysis. So I would prepare a sample, put it in the machine, the computer counts how fast they're going, where they're going. You can put different parameters into what you want to count as what, and it gives you a very accurate percentage of total progressive motility, which is very important if we were, say, freezing semen or something that we needed a dead-on accurate number for. However, particularly breeding on farm, me guesstimating that's 25% total motility or progressive motility is quote-unquote good enough. So we know we're in that ballpark, we know how many sperm cells are in each mill, and we can kind of calculate that breeding dose based off of that. In the past, we've shipped with plenty of success eyeballing it, and I would say there are plenty of places that eyeball motility. As the machinery is getting a little bit more affordable, I think we'll probably see a shift towards people utilizing more of that as well as we kind of progress. So as you can see, it's already died off quite a bit. So we want to kind of keep in mind what it looked like at the beginning. And then we'll also take into account the number we get from the densimeter. I don't know if you can see it here, but it says 321 million sperm cells per milliliter. So all the semen that we have collected, we can pour into a graduated cylinder. And if we were going to ship doses or something where we needed to be pretty exact on how much semen there was, we would definitely want to do that. So I have a 50 ml graduated cylinder. We want to pour it gently. We don't want to slam all the semen around because we want it to stay alive. So we empty out our sample, and we have approximately 25 mils of raw semen. For a stallion that dies off relatively quickly, once I've done my analysis, and even before you do motility, you can dilute it 1:1 with extender to hopefully help that semen live a little bit longer. I want to gently mix that together so it can stay alive a little bit longer as we kind of go through the other processes. So now that we have our motility that we estimated by looking at it under the microscope, and our concentration is measured by the densimeter, it can tell us a little bit more about the ejaculate that we have collected. So I measured the amount of semen that we had, and he gave us 25 mils of raw semen. If there are 321 million sperm cells per mil of semen, that gives us 321 times 25, which comes out to 8,000 million or 8 billion sperm cells. So that is how many sperm cells are total in that ejaculate. However, that's not all of the semen we have to work with, because when we looked at motility, we estimated that only a quarter of those were actually moving and going somewhere. So we need to take the 8 billion, times it by 0.25, which would give us a quarter, and that's the motility that we estimated. And that gives us 2 billion total sperm cells in the ejaculate to work with. So what that tells us is, if I were going to use this ejaculate to breed a mare on farm, I want to make sure that I put at least 500 million total progressive motile sperm cells in a single mare. So what that tells us is we have 2,000 progressively motile. We divide that by 500 million. So we get 4 doses from that single ejaculate. So we could breed 4 mares on farm with the semen that we collected today. However, if we were going to package a dose to ship to somebody, we need to account for the fact that half of those are going to die through the cooling and shipping process in the next 24 hours. So keeping in mind that we still want to put 500 million progressively motile sperm cells into that mare when it gets there tomorrow, we need to package twice as much. So we would need to package 1 billion sperm cells in a shipping dose to make sure we have the adequate amount to breed them with tomorrow when it gets to wherever we're sending it. So therefore we have 2 billion in this total collection that we've collected today, so we could ship 2 doses to somewhere else for them to breed a mare with tomorrow.